Hi, are you ready to learn with Teacher Jen regarding polynomials, definition, classification, and standard form? So again, what's in here about polynomials? 1. The definition. 2. The classification according to degree and number of terms. And the standard form. So what competency does this video answer? It's about illustrating polynomials. We start with the definition. I will first give a question, you try to answer, and then we check based on the definition. Which of the following defines a polynomial in one variable? There are four items here. I let you answer first, so I'll give you a few seconds. What is your answer? If your answer is letter A, I would say very good. Now, why is it that the answer here is letter A? Let's check the definition of what a polynomial is. A polynomial is a special algebraic expression with terms that consist of real number coefficients, I repeat, real number coefficients, and variable factors with whole number exponents. But you have to remember that the question is involving polynomial in one variable. So, from items A, B, C, and D, all the real numbers, all the coefficients are real numbers. But let us check the variables. In letter B, obviously we have here two variables x and y. So it's no longer a polynomial in one variable. In letter C, let's check. There is in the third term a variable which is in the denominator. So if we apply the law of exponent for this, then we will write this as 2, negative 2 times x, which is raised to negative 1, the law of negative exponents. And what is negative 1? Negative 1 is an integer, not a whole number. So this now violates the definition given. In letter D likewise, we have clearly here an exponent which is negative 1, which is not a whole number. While in A, the variable is x, the exponent is 3, the exponent here is 2, the exponent here is 1, and it is understood that the exponent of the variable factor in 3 is 0. That is x raised to 0. And what is any number aside from 0 raised to 0? That is equivalent to 1, making 3 times 1 still equivalent to 1. Thus, the answer is A. Try the second item. Which of the following does not define a polynomial in one variable? Again, we have items A to D, and if we are going to check, all of them involves one variable. So what could be the answer? And the answer is letter C. Why is letter C not a polynomial? Not a polynomial. Let's check again the definition. Our Q is all real number coefficients. And the second, variable factors are with whole number exponents. Let's check the coefficients. 6, negative 4, 7 for letter A, all real. 3 halves, 3, negative 1 half and 1, all real. In letter C, 5, 3, negative 4, all real. And in letter D, 5, negative square root of 2, 3, all real. So let's check the variable. If we take a look at letter C, in letter C, the radical contains a variable radicand. And according to your previous lessons, we can actually rewrite this radicand into an exponential form. How do we do it? So we have here the radicand x, and then the exponent is 3, then the index is 2. So that is actually x raised to 3 halves, And how do you classify 3 halves? It is not a whole number, it is a fraction. Hmm. But then you might again say, What about letter D? It also has a radical. Yes, it has. But look, the radical only has 2 as a radicand, meaning to say it is a real number. It does not contain a variable. X is not part of the radicand. That is a literal coefficient. Thus, the exponent of x here is still 1. So letter D is a polynomial in one variable, while letter C is not. Clear? So again, how do we know whether a polynomial is or whether an expression is a polynomial or not? One, you have to check that all the coefficients are real numbers. Second, you have to check the variable. Since we are dealing only with polynomial with one variable, there should only be one variable. Mostly, we will be dealing with x. Next, you check the exponent of the variable. It has to be a whole number, meaning to say from 0, 1, 2, 3, and so on. It does not involve a fractional exponent. It does not involve a negative exponent. There is no radicand, which is a variable. It has no denominator that is a variable. Those are the things that we have to take a look at when we consider polynomials. Next, for the degree of a polynomial, answer the question, what is the degree of the polynomial below? The polynomial is 8x cubed minus 5x raised to 5 minus 2x plus 3. The answer is 5. Why is the answer 5? Let's check the definition of the degree. The degree of a polynomial in one variable is the highest exponent of the variable. We're only dealing with one variable here. Highest exponent. The exponent of x here is 3. The exponent of x here is 5. Here 1 and again 3. The exponent is 0. So what is the highest exponent? It's 5, making the degree equal to 5. Next, what is the degree of the polynomial 3 halves x raised to 3 plus 3x raised to 2 minus 1 half x plus 1? Check again, what's the highest exponent? What is it? Yes, it is 3. Again, we take note, highest exponent. And the exponent of x, 3, 2, 1, and then you have here again 0, making the degree equal to 3. All right? Let's also consider classification based on degree in as much as we are already talking about the degree of the polynomial. Which of the following is a cubic polynomial? So the name is cubic. Is it item A, B, C, or D? And the answer is letter B. Why? Let's check how we name polynomials according to degree. First, we have here 0. If the degree is 0, I'm sorry, this is not supposed to be 0. It is constant. If the degree is 0, then we have here what we call a constant polynomial. And which of letters A, B, C, and D is a constant polynomial? We have a letter D. It does not have a variable as we see it, but actually it has a variable coefficient, and that is x raised to 0. The degree is 0. The exponent of x is 0. And again, x raised to 0 is equal to 1. Next, what about if we have here the exponent is 1? It is called linear. And we don't have an example of a linear polynomial from A to D. Then if we have here the degree is 2, we have quadratic, which is the lesson for grade 9. Then we have, if the degree is 3, then we have a cubic polynomial. Thus, we have here letter B is the cubic polynomial because the degree of the polynomial here is 3. Then we have 4, quartic, and that is item letter A. And we have here, if the degree is 5, then we have a quintic polynomial. And of course, for the others, we can just simply say 6th degree, 7th degree, and the like. So that is the classification based on the degree. How is it? How about if we have here now, based on the number of terms? A while ago, classification based on the degree. This time, classification based on the number of terms. So we have, which of the following is a trinomial? Trinomial is a classification according to the number of terms. Clue, take a look at the prefix. So what is the answer? We have letter C because what is a trinomial? Let's check. We have the number of terms and then the name. We have, if we only have one term, we have monomial, and that is your letter D. Then if there are two terms, we have a binomial. We don't have a binomial example. Then we have, if there are three terms, then we have a trinomial. That's one term, second term, third term. So the answer is C. Then if we have four terms, we have what we call quadrinomial. And letter A and letter B both have four terms, so we have quadrinomials here. And then in general, we just simply say multinomial. All right? So we have their classification based on the number and number of terms and the degree of the polynomial. Thus, how would you name 2x cubed? Give the correct name for 2x cubed. Is it a quadratic monomial? Is it a quadratic trinomial? Is it a cubic monomial? Or is it a linear binomial? Combining now the degree and the number of terms. So what is the answer? It's letter C. It's a cubic monomial. What is the degree? 3. How many terms are there? 1. So it's a cubic monomial. All right. Now, it would be easier for us to determine the degree of the polynomial if we arrange the polynomial in such a way that it follows what we call the standard form. What is the standard form of the polynomial? We have the polynomial in one variable, and in this case, x is equal to, careful again how we read, a sub n times x raised to n plus a sub n minus 1 plus x raised to the difference of n and 1 plus a sub the difference of n and 2 times x raised to the difference of n and 2 plus, and so on, plus a sub 1 times x plus a sub 0. That is the arrangement. That is the standard form of the polynomial. And what is it telling us? It is telling us that we arrange the polynomial according to the exponents. Since we have an n minus 1, that means to say it is decreasing from the highest exponent to the lowest exponent. That is how we arrange the polynomial. Likewise, in this standard form, there are specific terms that we have to remember. One of which, we have the very first term there, which is a sub n times x raised to n, is what we call the leading term. It's the one that leads all the different terms of the polynomial. It's the one that we write first. And in the leading term, it's already color-coded for us to easily remember. The a sub n, or the numerical coefficient, is called the leading coefficient. Whether that is the highest real number, the largest real number, or the lowest real number there, it does not matter. As long as that is the numerical coefficient of the leading term, then that is the leading coefficient. Likewise, in the leading term is the exponent n, and that is the highest exponent, therefore, that is the degree of the polynomial. All right? Then we have another term to remember here. What is a sub 0? A sub 0 here is the one without a variable, as if without the variable, it is the constant in the polynomial. So don't forget these terms because we will keep on using them as we move along. Let's practice. Example number 1. Express the polynomial in standard form. Negative 5 plus 2x minus 5x squared plus 8x cubed. Likewise, I will be asking other questions aside from the expression to standard form. So, to write the standard form, again, you have to remember that you have to arrange the terms from the highest exponent to the lowest exponent so that we have this. You have 8x cubed is the one with the highest exponent. Carry with the terms the operation before. So we have positive 8x cubed. Then you have here second degree term. You have negative 5x raised to 2. Then you have here positive 2x, and you have here the constant term negative 5. All right? So that is now the standard form of the polynomial. Next, what is the leading term? Again, the leading term, when we have already arranged that to the standard form, is the first term that we see. So we have an 8x cubed. From the leading term, we can identify the degree. And what is the degree? It's the exponent of x, which is 3. Then what is the leading coefficient? Again, we get it from the leading term. And the leading coefficient is 8. There. And of course, we also have to identify what the constant is. And the constant is negative 5. I have arranged it in this manner so that we can see where we are getting these answers. Let's have example number 2. Example number 2. Express the polynomial in standard form. You have 12x squared minus 7x plus 9x cubed. Again, write first the term with the highest exponent, and that is 9x cubed, followed by 12x squared positive, then our negative 7x. So you will see here 3, 2, 1, the exponent. Then you have to determine what is the leading term. The leading term is 9x raised to 3. What is the degree? It's from the leading coefficient, we get 3. What is the leading coefficient, the degree, the leading coefficient? That is 9. And of course, what is the constant? Where is it? Everything has an x, and we said the constant is the one without the x. Therefore, there's none, so we say 0. 0 is the constant for this particular polynomial. And the last example for this, we have express the polynomial again in standard form, then identify the terms necessary. 3x raised to 5 minus 4x raised to 4 minus 7x raised to 3 plus x raised to 8 plus 2x squared minus 3x plus 5. So what is the standard form? The highest exponent is 6. So we have there x raised to 6. Then the exponent 5, exponent 4, exponent 3, exponent 2, exponent 1, and the one without the variable or the constant. All right? Then, we identify what is the leading term. And what is the leading term? X raised to 6. Then, what is the degree? From x raised to 6, we get 6. And then, what is the leading coefficient? You might say none. No. If you have here, there is no clear real number there. It is understood to be 1. So the leading coefficient is 1. And we have the constant term, the one without the variable, which is positive 5. Then we have the constant is 5. So there you have it, ladies and gentlemen. Standard form of the polynomial, and also identifying what is the leading term, the degree, the leading coefficient, and the constant. I hope that you have learned something again from Teacher Jen. So thank you for watching and listening. See you in the next video. Goodbye.